Okay, we're looking at a 2005 Chevrolet with a Duramax diesel in it, parallel battery system. We're going to do a test of the charging system, trying to locate why one of the two batteries does not charge as well as the other. Okay, looking at connection to battery number 1. All right, we have a standard connection there. All right, hot and ground. Then when we go, we will look at the alternator. As we look at the alternator, notice that we're connected down actually to the alternator post and then to the ground on the alternator case. This is a case grounded alternator, so we'll be able to take and use that as part of our voltage system. Then on the opposite second battery, we have actually a simulator for load. It will add a resistance when that switch gets changed, but we are basically connected to the positive and negative of the battery. You can see the connection at the back going to that battery. This is what the battery connection would look like ordinarily without the load simulator in place. Once you have the cables connected up front, you simply route them safely to the interior of your vehicle, where you're going to attach them to the Signalrouter and your multimeter. Simply we'll set up the truck. I go ahead and set the battery. We can see that on battery number 1 I'm showing 12.26 volts. I'm going to go ahead and start the truck at this point, and let's see what we have. Actually, let's look at the second battery too. 12.28 volts on it, so we're looking good through the simulator on the load, and we have the voltage 12.3 showing that's the combined voltage at the alternator, and showing that it's also, note that it's in reverse polarity. We're going to go ahead now and turn the polarity switch over to change that polarity. We'll set our min-max so that we can take and actually see the voltage when we go to crank it, just as a rough proof of how the starter system is doing. So now we go ahead and we crank. Now we can look at the min-max voltage. Okay, max was 1466 once the alternator fired. Okay, minimum it only dropped to 10.05, so the batteries are holding up well. Okay, so now what we're going to do is we'll take and go ahead and go through and look at the battery voltages. Now what I'm going to do is I'll change over and we look at what's charging right now. Turn off min-max. Okay, and you notice that this the negative is back up. We can go ahead and change the polarity switch. Makes no difference whether it reads in positive or negative. All right, we're looking at 1455, 56, so that battery is charging nicely. All right, and then we will have battery number 1, 1457. So they're within basically 10 millivolts of each other. So they're charging quite fine. So there's really not a problem. I am going to introduce the problem now by changing the load, and we'll see how what the effect is, and then how to determine which leg, power or ground, that this is on. I've now added a resistance on battery number 2, okay, by turning the switch. So we'll now look at the batteries again. Okay, battery number 1 is consistently charging about 14.596. Okay, battery number 2, okay, is actually now, because of the resistance that was added, only charging at 13.39. Obviously, on a vehicle, if you had an imbalance like this on a parallel system, this is going to cause you significant difficulty in that battery, and that will wipe the battery out. The question is whether it's a wiring problem or a battery problem. So we're going to go ahead and work to prove that now. Let's look at what the alternator is actually putting out again. Okay, alternator's putting out 14.67, so it's doing quite fine. All right, now what we're going to do
is we are going to take and look at the leads of that alternator. Okay, so what we're going to do first is let's look at the hot leads and see if any of the hot leads are having a problem. So we're going to take and we're going to look at the voltage drop. So now what I am measuring is the point between the third port green and the second port red. Okay, so we know that these are both hooked up hot. Okay, and now I can compare those two. I'm going to go ahead and switch to millivolts here. All right, so I've got about 45, 46 millivolts between those 2 points. Let's look at how it is on the other leg. Okay, I've only got I got about 54 millivolts. Now that difference is significant, and you'll see why in just a moment. Okay, so as we go ahead and move on now to check the other side, we'll come back up here. We have the alternator back up, and notice it goes into over limit. That's because we've gone up. Does not bother the meters to go into over limit. We're now there, 1468 again. Now let's look at the ground side of this circuit. Right away on the ground side of this circuit, it just showed us that we've got a 1.33 volt drop on that ground side. So it is not, it's got a resistance in the ground circuit. Dirty cable, bad cable, any of those could be a problem with that. And then as I check over to the other cable, okay, you can see that my ground drop, we'll switch back over to the millivolts again, is only 6.45, somewhere in that range, and it so that you can see the difference between the two voltages. So we come back, we look again, it's over limit in millivolt, so we go up to the voltage because we have a larger problem than millivolt can handle, and it's 1.3323332. Okay, so we can see right easily, quickly in that time frame that I have a cabling problem. Now if I go out and fix the cabling problem, you'll notice that the voltage drop will go away. Now with the cabling on that ground side repaired, okay, I just turned the switch back. Once that is repaired, our ground side voltage drop is now 0.02. Okay, we can compare that with the ground side voltage drop on battery 1. Now, on this, you're going to see a higher voltage drop because there's more currently charging on battery 2 to make up for what we lost during the time that we had our voltage problem. So if we look at the two voltages, 1462 going into that one, this one will say 1463 pushing up all the way to 64. Okay, so as these batteries equalize, so will the voltage drop. That's how quickly and easily you can analyze a charging system in a parallel system, whether it's with remote batteries, possibly in a compartment behind the seat. The extension cables allow you to make all your connections ahead of time and then cycle through it like this. Notice that there's no in and out to test the voltage drop between the battery cables. You don't have to climb in and out of the vehicle. You make the connection to the two batteries and the alternator. Everything else is done for you with the connections and the connection box.